Looks like we're ready to start. So I just want to say welcome to the RCR Wireless News Webinar. Our webinar today is how network slicing promises to unlock the value of 5G. I'm your host, Susan Rambo, 5G editor at RCR Wireless. Oh, excuse me. And our panelists today are Jason Marchek, the Research Director at Global Data Technology, and Ihab Mana, Solution Architect at Expo. So the way today's webinar will work is I will talk briefly about RCR Wireless's new report on network slicing, followed by Jason Marchek, who will describe what network slicing is and what's happening in its development right now. Ihab Mana will then go into more detail about how network slicing will work and what is needed to achieve successful network slicing. So we should have some time at the end to answer your questions. So please enter your questions to Jason or Ihab in the question box as we move along. We will try to get to all of them at the end. And also know that a copy of this webinar will be posted with slides to our website shortly after this show. So a little bit about RCR Wireless. RCR Wireless News has been covering the wireless communications industry since the early 80s. We inform our industry readers with breaking news, enlightened features, and invaluable insight, such as the webinar today on network slicing. So network slicing is not just a theory. It has been in the news this year as the 5G efforts accelerate. We've been seeing proof of concept, partnerships, and products come out of this year, and our panelists today can help us make sense of these. Also about our report, which we will send to you as a subscriber to this webinar. We'll send that after the webinar. Here are a few takeaways from the report. A lot of technology will be going in to make 5G work, and it's definite that network transformation is needed, and it's a key element. The market is also getting closer to production deployment of network slicing, but it focuses on 4G at this time. And the report also reviews use cases, case studies, state of readiness, and the next steps in network slicing. So without further delay, I'll turn this over to Jason Marchek to describe what network slicing is. Jason?
All right. Yeah, thank you very much, Susan. So before I dive in, I just want to show a couple slides, and this is really going to be for further reference, later on, and if you want to go back to the slides. But for those that don't know who Global Data might be, I just want to let you know that we're a global business intelligence provider that operates in most of the largest industry segments in the world, telecom and media being one of them. If we move on to the next slide, Susan, just here's another slide that'll, details our technology practice. And really the takeaway here is I think if anyone has any questions or needs any information, you can go to globaldata.com or feel free to contact me directly. And I think my contact information will be provided as part of these slides. So with that out of the way, let's go ahead and dive into the network slicing overview. And then after that, we'll kind of get into the real meat of the presentation, which is eHub. So network slicing is, I think Susan mentioned, is not exactly a new concept. In high tech terms, I think the fact that we've been talking about it for more than 5 years might even qualify it as, kind of a well-worn concept in quotes. So while I'm not 100% sure that it was a thing during Confucius's time, I do believe that the above description is widely enough known that we can probably consider it a maxim, or at the very least something that's pretty much universally accepted. Now, with that in mind, I think a lot of the attention to the potential for, a lot of attention has been paid to the, potential for dynamic, user-defined, on-demand network slices that, a 5G world will enable, has kind of eclipsed the fact that network slicing is very much applicable in a 4G and or, a fixed line network environment. So, I think naturally without the ability to dynamically support the turn up and tear down and scale in and scale out of network resources, And probably importantly, resources needed to ensure SLA support and security requirements of that thing. There can be a static nature applied to the trial and POC activities that we've seen to date. But nevertheless, one of the things that we do know about network slicing circa 2018 is that there are use cases that can be supported today, even in advance of 5G deployments. And I think that's something very important to keep in mind. If we move on to the next slide, Susan will go ahead and look at what network slicing can be. And I think that, if we look at it, what it is today, on this slide, we'll try to draw a rather simple picture of what it could look like in the future. Now, I'll comment in advance that this looks nothing like the box diagrams that are typically used to depict all of the network domains and, maybe the overarching management and orchestration capabilities needed to produce network slices. But I do think it helps to simplify the concept and explain what network slicing is and what it needs to be, I think, as we move into the 5G era. Now, first and foremost, if we're envisioning a future where potentially millions of network slices are able to be supported, where they're dynamically set up or torn down, where they all support very specific SLA parameters and are being defined by users and being created on demand, then I think there are several important criteria that we're going to have to meet moving into this paradigm. From a network perspective, a slice has to be able to be provisioned on an end-to-end basis. I think that's a fundamental capability, and that spans really the RAN, the core, transport networks, and it also includes the ability to provision and support multiple types or multiple classes of user equipment. This will also require closed-loop network management and business operations processes that span the entire network layer and applicable UEs, as well as the service layer. It's also going to require robust security features that are going to be in place at most, if not all of the points, in this end-to-end process. And so I think, the next question probably becomes, if we're going to realize this vision, what does it require? And so I think if we move on to the next slide, we'll talk briefly about that. And, some of the requirements, again, at a relatively simplistic level, again, with the promise that Ehab is going to dive into more specifics in his portion of the presentation. But if we do, accept the premise that network slices need to be implemented on a massive scale in a very, very flexible nature and really support hyperscale type economics, then network virtualization is probably the fundamental underpinning that we're looking at. In fact, if we look at a lot of the technical discussions of what needs to happen to enable end-to-end network slicing, one of the common themes is that the user and the control planes need to be separated in each one of the domains. Now, this is, of course, perhaps the overarching concept of network virtualization. So, I think that it probably goes, it can be taken for granted that without network virtualization, we don't really have the ability to provision dynamic network slices and what we need to do to bring it into the 5G world. Once we have that prerequisite in place, and obviously we're moving in that direction quite rapidly, then I think 5G can come in to complete the picture. And here we're talking about new radio standards. We're talking about distributed edge compute solutions to support ultra-low latency requirements, as well as some of the dynamic digital native business models that both operators and the ICT service buyers are moving towards. Now, once we have these kind of cornerstones in place, there are still questions of how to best bring network slicing capabilities to market. Over the course of the past couple slides, I've painted a picture of perhaps the ability to provision nearly endless iterations of fully bespoke slices. I would say that's certainly where we're headed towards, and that's what we're aiming for. But if we think back to what we know about network slicing circa 2018, the question is that really the best way to get the ball rolling? So if we go to the next slide, I think we'll talk a little bit about, kind of, I guess, under the mantle of maybe walk before you can run. There does seem to be a movement being espoused by many in the industry, and it related to the idea of defining generic or perhaps predefined network slices So to help the industry put a framework around, the myriad of steps and capabilities that are going to be required to support network slicing. One of the leading proponents that I've seen of this approach is a GSMA. So I guess, under the mantle that I've been operating under these past few slides here of keeping things simple, I like the above chart. I mean, I think the slide or the chart on the screen here, I think it does a good job of depicting what a framework of generic slices might look like. So if we use this diagram as a guide, we can see that operators might define slices aimed at supporting, say a subset of industry use cases, such as IoT or ultra broadband or ultra low latency. At a high level, I think this describes probably a horizontal approach to network slicing. At the same time, it also demonstrates that multiple horizontal slices can be used to support different UEs within a use case. And I think here, in this case, we're talking about, we see an IoT slice and a broadband slice being used to support an automotive use case. So this could, and what I mean by that is multiple UEs within that automotive use case. So this could really be viewed as a vertical approach to using network slices to support an industry requirement. Now, if we go on to the next slide, and this will be my final slide before we move into the next portion of the of the presentation. If we think about the previous slide, that was kind of the generic, here's what a IoT slice might be, or here's what a ultra low latency slice might be. This slide here, takes those concepts and tries to put some real world examples around them. And in this case, I'm using Nokia. Most of the major systems vendors have these slides and have these examples that we can point to. But I like this one because it does tend to show how the horizontal and vertical approach might be implemented in a few real world scenarios. So I think if we look at the 5G port and the 5G industrial automation examples, these could be viewed as network slicing being used to support a horizontal approach. Whereas the V2X example demonstrates applying network slices to support different use cases in the same vertical. So in this case, we're talking about public safety vehicles, one set of requirements being used or provision, one set of slices being used to support the requirements for V2X connectivity for public safety vehicles, and then another slice or set of slices being used to satisfy the requirements for consumer vehicles. I think this slide also does a good job of pointing out that in order to make any of this happen, an ecosystem of partners is required. None of this is going to be done solely by one provider working with one end user. I think it's going to require equipment vendors, platform suppliers, connectivity suppliers, players in the various vertical industries. And then just to close here, I think that while these examples are taking place today, they're almost certainly bespoke projects. It also provides a glimpse of what generic slices could look like. We could certainly see a generic factory automation slice that a lot of different vendors can offer to the market. And so I guess just to close before we turn the ball over to Ehab, I hope that this sets a stage for a more detailed discussion of exactly what needs to happen, especially from a management and operations perspective, in order to enable network slicing in a 5G world. And so with that, I'll end my portion of the presentation and pass things back to Susan to take us into the next part of the program.
Thank you, Jason. Ehab, you're up.
Thank you very much, Jason, and thank you, Susan. So next slide, please. So I will actually take this presentation, the same aspect that Jason described, from a different perspective, focusing on why operation and service assurance is going to be crucial to the success of network slicing and 5G. Next slide, please. So we will see that the 5G is really pushing the envelope with the network, pushing the envelope with operation, and relies heavily on these new technologies and new trends like NFV, SDN, and cloud-based architecture. And from that perspective, we need to see actually how all these things ties together and what is the impact and what are the areas of opportunities. Next slide, please. So if we look at today in 4G, we find that user experience, experiencing content is really the center of most of the services today. And that requires somehow a set of SLAs and a set of network behavior that is supported by 4G. It took us a little bit of time to get there, but that's basically the center of what the network is providing today. If we look at 5G, we found that we're actually opening two more fronts. One is IoT, which really it's not about content to the user, it's more of the users and the IoT and the things that the users are using, contacting the network for services and for further components that are required to make the whole service works. And then we have also another set of services that basically real-time interaction between components in the network and devices or connected car or any of those kind of services. And you can see here in the right-hand side of the slide that how really 5G is pushing the envelope to meet the requirement for these additional and emerging services. The reality is that in the network today in 4G and before that, we somehow knew what kind of services that we provide the user, and the whole network was optimized to provide those services. And the span of control for the service provider was, providing the service. In 5G with IoT, connected car, and these emerging services, it's actually become more complicated because not only the service provider, but other players and stakeholders have access or influence on the service as well. And this being categorized in 5G into really three main groups is the enhanced mobile broadband, which is basically the services we have today with enhanced experience, the ultra reliable and low latency communication, which is really focused on the real time, things like connected car that requires low latency and real time aspect. Then we have the massive machine type communication, which is basically focused on IoT, like devices at home and monitoring, all kind of aspects in the smart city and so on. Next slide, please. So, okay, so now we know that there is a whole set of new services are coming, and they're not going to be managed the same way. They're not going to be, it's not going to be operated the same way. The business model is also not the same. So what are really the main aspects that will help us architecturally or required for 5G? Now, first is reducing the life cycle of creating these services. We cannot take years or even several months to create them. We have to create them quickly to respond to the market. So that's the first aspect, and we're going to cover that in the rest of the slides in more detail. The other aspect is all IP infrastructure. Well, today we already have all IP infrastructure. What is different? The big difference are two things. One is SDN, basically having a software-defined network, so we have a control over how the network behave and optimize itself for a specific service. It's not one size fits all IP network. It's basically you have the flexibility to define the protocol and define the network behavior to optimize it for the service. And then we have network virtualization, which will enable us to not to deploy physical function with the long life cycle of deploying these functions. We actually can have them virtual pieces of software that can be chained together to provide the service and also enable us to choose the right one. We choose the right function from the right vendor and with the right characteristic to actually fit this specific service. Then finally, there is new aspects that coming to mobility specifically, which is Cloud RAN and the new architecture for the central office. So the traditional central office was mainly lots of equipment from different vendors with different operation, different expertise, different skills. Now we do have the ability to actually have one type of skill, cloud-based RAN that on the ground, you need only one type of skill to maintain it, but remotely, it has the flexibility to add functionality to it without adding the complexity of maintaining this Cloud RAN. Then, of course, mobile edge computing, which is going to enable a lot of services that require massive processing, like AR, VR, like augmented reality and virtual reality, that will require as close as possible to the user ability to provide processing power. And of course, the wireless part, where we have the massive MIMO and beamforming to really make sure that we have the latency and the capacity that is required for these services. Next slide, please. So having said that about NFV and SDN and the cloud and network slicing, what it actually means for us, it actually will mean a high velocity of changes. There will be the velocity of changes that things that can go wrong is much higher than the ability of any manual operation. So automation is not really nice to have or cost reduction. It's actually a way to survive. So it's going to be very fundamental to operating the network is automation. Now, what is really the key pillars for automation? One is good real-time visibility, and we're going to cover that in the latter part of the slide. So all layers need to be covered with visibility from layer 0 to application layer, but also end-to-end aspect where you provide the end-to-end visibility to actually how the user is experiencing the network. Then the second aspect is big data and policy infrastructure, where you can actually implement on the fly the policies to react to the events and automate the remedy, or even become proactive and see if there's a degradation and provide a remedy to that. Then finally, to actually wrap all that with a system that decouples the operation from the details of the network, you need to have a well-defined intent-based modeling of operation, so that the people who model the operation don't have to be expertise in the network and the details of the network. Their intent is always met, no matter how the network change or the design of the network change. So that's basically what's needed to make sure that all these technologies are glued together to provide a network that can meet the demand for these new services. Next slide, please. So digging a little deeper into the network slice is the fact that what is a network slice? And actually, there is a question about, what is the difference between network slice and trunking, in voice? It is basically an end-to-end network and function as well. Not just network, but also the function associated with these network that support a specific service, optimized to a specific service and SLA, and also has its own behavior and security aspect, meaning what happened when the network have a problem, what happened if the network need to scale. All these policies are associated with this network. So that's we call it, that's the horizontal aspect of the slice. That's way more than what was done by just partitioning a piece of a physical network that all manage the same way, more or less optimized for the same services. Here you have the flexibility to actually really slice the network and not just optimize it for the service, but also you can optimize it operationally for that service. And we will get to more details about that. And this was not possible until NFV and SDN, because SDN give you the flexibility to actually build protocols and behavior for the network that is specific to the slice. And also NFV enable you to provide virtual network function and service chain that is specific to this slice. It's not an infrastructure that is you have a slice from. It's basically you are building a whole different network service chain that is optimized for this service. And once the network slice is created, here is another aspect where testing and monitoring is extremely important. We used to build the network in the lab and test them, and then they're basically like a cookie cutter, like a component in a bigger network, but they're all basically the same. So whatever behavior is provided in the lab should be, when you scale it in the network, should be provided the same more or less. But network slice is actually created virtually in the cloud, and the components can be from different vendors, and also the requirement can be different, and the scalability also can be different. So you actually need to test it in the cloud in the exact behavior and the exact situation that it will be used in. So that's why testing the cloud, testing the network slice is extremely important. Next slide, please. So I guess here in this slide, we want to show why one size will not fit all for 5G and network slicing. If we take, for example, enhanced mobile broadband, we find that the number of gigabit per second rate is the most important requirement, and that's how all these services are geared toward pushing content to the user. But if we go to mission critical services, we found that reliability is very important and low latency. So it's basically not optimized for pushing or caching or seeing the quality of video, for example. It's about specific protocols, specific requirement for a specific application, that reliability and latency is the most extreme requirement. Then finally, when we look at massive Internet of Things, and we find that the coverage is the most important part of the service. Missing some devices is probably will be missing revenue in a way. So this is really shows that the really one size fits all for the network is not going to be the way to build a 5G network. Next slide, please. So when we look here, what is the high level requirement to actually build an architecture for 5G, given all the technological component that I talked about earlier? They're there, they work together. What is really the main requirement? The first requirement is to support new cases quickly, meaning no matter how radically the use cases and the services are different, there should be a possibility to build a network slice and build a network that is optimized for this particular service. So that's the first requirement. The second requirement is looking at the deployment option, is how fast we can deploy these services. So NFV and SDN and DevOps in general will enable us to actually deploy these services quickly and start with simple deployment and start building on that and make it more complex as we go. So it's not a waterfall model, it's more of an agile model. So that's the second requirement. The third requirement is tools. Tools will have to be different. It cannot be more of a only visualization of the problem, but it also has to be interactive automation and orchestration to actually remedy these issues and solve them. That's one. And second, the tools also for designing these services has to be friendly to people that may not have knowledge about the network, may not have knowledge about the protocol, but rather provide an intent-based tool to just describe the intent of the service, and the tools will help in creating the network that can support this intent. Then finally, the expectation is high on these services. So the speed of creating these services has to be quick. The responsiveness to issues has to be quickly, but also the cost of some of these services has to be low in operation as well, because otherwise some of these services may not be viable economically. So it's very important to meet these four cornerstones for building a 5G and 5G service. Next slide, please. So now this is going to the next level and describing what is really the difference between the network, the traditional network, and operation, and the operation for a network built using cloud, NVSDN, and 5G. So if you look at the traditional network, we find that we have the network, we have all the FCAPS function on top of that, and then we have the network operating center, where it's really focused and optimized on the network and the behavior of the network. So it's kind of a monolithic system that build and optimize for set of services, and our focus is in the network, assuming that the network behavior is mapped to service behavior. But we learned that that's not necessarily true. Basically, if we focus on the service side, then if everything is built in mind with the service and the service behavior, then the network is just part of that. So if you look at the right-hand side, when we look at 5G services, we actually migrate from operating the network to operating the service. And since we already agreed that there will not be one size fits all network and there will not be one size fits all service, then we actually have to build on top of the network slice the whole operation for that service. So, and that's again as a follow-up to the same question of why network slice is different than the original trunking, is the fact that actually the network slice is also an operational slice, meaning the operating this network slice will be different based on the service. So in this case, we are actually focused on providing an operating center that focus on monitoring the service and automating all the aspects of keeping the service reliable, resilient, and available. Next slide, please. So looking at what is the service operating center can offer. So the first thing is providing the holistic view of the service and the network and the performance for the user. This information needs to be available, and also there has to be tools to find out how to improve the customer experience. So it's really focused on improving the customer experience from the data. And the second aspect is there need to be an integration and correlation between the data for the various layers. So layer 1, 2, layer 3, and layer 4 to 7. Has to be a way to correlate this information and drive actionable actions out of this to actually remedy the network and fix issues, and also provide insight in how to improve it. And there has to be a cross domain and correlation as well. So there has to be correlation between the topology and the degradation, for example, and the alarms. There has to be a correlation for the quality of the service and the other aspect of the network, like latency, like jitter, and all the main telemetry of the network performance. And then there's also has to be a relation between the efficiency of the call and other aspects of the network, like congestion and also equipment overload. What is really different in a VSDN from the physical network is the fact that we don't now have the box. We don't have the element manager, network manager that provide specific alarms for each box. It's a shared resource, which is the cloud. So correlation between the cloud performance and what the cloud can provide in terms of resources to the network function is extremely important. And we will get to that point later on in the presentation of how cloud nativeness is extremely important to achieve that. Then finally, look at the hotspots in the service and the hot points where there is an importance to correlate the CRM data to the performance data. Meaning where is the area where most of the problem come, and how that correlates to issues like degradation, issues with handoff, and so on. Once we achieve all the above, then the role of machine learning and artificial intelligence comes, where actually how can we automatically deal with this massive amount of data and extract actions to react to the network. So it will not be no longer possible to look at all this data and drive manually these actions, even if you drive it for automation. So the AI aspect and machine learning would be very important. Next slide, please. So this is more of a visual picture of what I just described in the last slide. So the base for all this, it has to be good monitoring and good probing in the network, so that we can monitor the network passively and extract behavior data. We can actively test the network to emulate the user experience at any point. So the combination of the two, of the passive and the active, is very important. And then, of course, data that comes from the different virtual network function, from the SDN, and from the cloud. So this is basically, really the main three component. Then finally, the third-party data, meaning data that comes from the other means of probing and other means of monitoring. So all this data goes to really two main areas. One is the multidimensional analytics and deep analytics for non-real-time data, meaning things to learn the behavior of the network and drive insights on how to automate. So the right-hand side is more of whoever running the service is to learn how to automate the service. Then once that's understood, whether manually or using machine learning and AI, then the second aspect comes, which is basically in real time, how can we get the same patterns and react to them, either escalate them to a care or forward them to a policy, or even fix them locally in the domain. So the implementation of managing the network and operate it will actually exist on that left-hand side. It's very important to make sure that we have a real-time topology for the network, because mapping alarms and issues to the topology is what's going to help us to find root cause and common cause analysis, and hence providing the remedy for fixing these issues, either by scaling or reestablishing connection, whatever the action for that particular issue. Next slide, please. Quickly on this slide is just to show the difference between, the physical network and the network built based on virtualization and data center. This is just to remind us of the fact that we used to deal with equipment that provide us through element manager and network management, alarms and performance data. We also, that was not enough, so we had to also passively and actively monitor this network from the outside to find the issues that cannot be found or expressed by the equipment. Today we have other aspects. We have, with virtualization, we do have the Cloud RAN, we have function, we have the virtual EPC, virtual IMS, and we have the OSS and video services. They are running in different clouds, a distributed cloud. These virtual network function themselves, the VNF managers have data about how they actually performing and how the cloud is supporting the requirement. But also we have a virtual infrastructure manager, which the VIM, which basically provide information about how the cloud itself is performing. Then finally we have is the controllers that manage the transport and setting up the connectivity between these components. Really, they're all orchestrated. Correlating this information is what's going to finally provide us with the overall performance of the network. So it's totally different than the existing traditional network. It's more complex. It involves more components. Some of them are cloud native and some of them are not. So we have to bear in mind that really a new systems are required to support that. Next slide, please. So quickly, this slide actually showing that how service assurance is required throughout the DevOps lifecycle. So before, the service assurance existed during the operation, during when the network is operating. Some of it was also used in the lab, but they were kind of not connected. There could be two different tools. Where in the cloud, you actually, your cloud is somehow it's your lab as well, which means that while designing your services, you actually develop them in the cloud. So throughout the life cycle of the service, the same components, whether it's a simulation, which simulate large number of users using the service, testing the NAVI or testing the cloud infrastructure, testing the slice, could be used during the development side, but also can migrate to be also same tools used in real time and orchestrated as well. Next slide, please. So what is really the main requirement for providing a continuous integration, continuous development, service assurance? The first is open API. So the service assurance has to provide, and the probe has to provide open API so they can be used by the higher level system in an open way. And also modeling. So the modeling will help into bridging this gap between the intent and the capabilities of these probes. Then programmability and being designed in microservices fashion. That will help in having these components can be embedded in any service development or operation. Then the cloud nativeness, and cloud nativeness is very important because that will help to automatically manage those components the same way as a virtual network function and the SDN network is managed. So you don't have silos of operation to manage that. Then simulation tools. This is going to be extremely important because it's not just for the lab. We continuously be developing the service in the cloud, which means that we continuously need to test it and push the service to the limit so that we know that the service can actually meet the requirement. And those limits sometimes are not known during the designing the service. It can be known also in real time. So having simulation tool for real time is extremely important. Then finally is in design tools for service operating center, meaning the center itself, the tools used for operation require design and creation tools to create those operations, whether it's policies or testing or coordination, orchestrated tests, blueprints for orchestrated tests. All these aspects need to be created by user-friendly tools. Next slide, please. So just about Expo, we today, and we've been for 30 years, having these technologies already. We are at the axis of the network, whether it's mobile or fixed, with handheld tools and probes in the core of the network. And also we have analytic tools and topology tools that help in doing this service assurance and also monitoring and testing. So the base technology and the understanding of protocols and operation is very well established within Expo. Next slide, please. What really going to happen, and it's happening today, is that how we map those solutions into the 5G architecture. So we look at the aspects in green, for example, the simulation, we already talked about that it's required during developing the service, but also during operating the service. All the aspects of monitoring, whether it's active monitoring or passive monitoring, and fiber monitoring as well. And on top of that, there are analytic systems that actually correlate this information. So that's all these aspects are available, virtualized, and meeting this earlier requirement that we mentioned, the cloud nativeness, the microservices, open API, and modeling. So that will make them available for developing the service. Then there are other aspects we're already covering, like optical testing and on-site testing. That will never go away. That will always be required. What's going to be different is that the fact that the data that comes from those on-site testing, whether for optical network or for Ethernet, need to be fed into the same system with the open API and provided to become available for the service operating center. So with that, I conclude my presentation. Back to you, Susan.
Okay, thank you, Ihab. It was very thorough and interesting. And So now it's your chance to ask questions. So continue to drop some questions into the question box, and I'll read some of the questions, and either Jason or Ehab can answer. Here's one that Barry asks. He says, I don't understand what you mean when you say SDN defines the protocol. 3GPP does not change protocols. We're still IP with GPG bearers. SDN, NFV is about space, power, expansion with lots of carriers struggling to figure out which services to put NFV solution. Did anyone want to take that?
I will take that, Susan. So I think definitely the existing network, and maybe for some time, the known protocols are IP. That's definitely what's going to happen for some time. But we also don't want to forget that SDN can actually open the door for other protocols that are optimized, or even optimizing the way of using IP for specific services, either for optimizing it or even the architecture itself. NFV and SDN is not necessarily going to be implemented by taking, let's say, a network that has 10 boxes connected. We take them and take the 10 virtualized boxes and connect them. We actually can build an architecture that is different, that can be built in a hierarchical way that's more optimized for a specific service, for specific security. So what I meant is that we don't have to build a network with the same concept and the same architecture and just scale it as today IP network. We actually can, with SDN, we have a degree of flexibility to build better networks.
Okay. Next question. Gerardo, considering the requirements of each slice over the different layers of the actual network, from the physical to the service itself, how advanced are the industry efforts for developing such orchestration, considering the different vendors and technologies present in each layer?
You know, this is Jason. I can take a shot at that one, and then maybe toss it over to Ehab for a more detailed answer. I think that it is a definite question in the industry. Not only for network slicing, but just in virtualization in general, is how much orchestration is needed and where is it needed, and, you know, the industry looking for guidance to that end. As far as industry organizations are concerned, I think the MEF comes to mind with their LSO initiative, trying to define templates for where orchestration is needed and, you know, how much throughout the process. So I think that's definitely something on the networking side. I think the TM Forum is doing similar things with respect to you know, how the OSS and BSS layers interact with the network from an orchestration perspective, and obviously there's a lot of vendors out there that are, you know, that have solutions and certainly have visions on how you know, how orchestration needs to be implemented in virtualized networks depending on what the end goal is. I think as far as network slices are concerned, it's probably a fair statement to say that one size is not going to fit all. There's going to be different requirements and different levels of orchestration that are required depending on the complexity of how many slices. You know, I can just, seeing like the templatized slice example, I can see there being some guidance on, you know, if you use the factory automation slice as it's defined here, here's where you might need orchestration and here's all the different points. But as we get to kind of on-demand, bespoke slices being provisioned by end users, that's going to require quite a bit of complexity that is probably still to be determined. But Ehab, I'll let you comment if you have anything else to say.
No, I agree, Jason, for about everything you said. I think, and also I don't think network slicing or orchestration need to be developed in a waterfall model where we develop everything or not at all. I think the cloud gives us this flexibility. Today, you can build a service chain of a set of vendors, and then you can build another service chain parallel to that with another set of vendors. Whether they are orchestrated or not, that's, in my opinion, is just, you know, the step one in given the flexibility to not to have to build the network in the lab and just go and use the same vendor and go and build the whole network. You actually have the flexibility with virtualization to really build a separate network with separate vendors, just as a start. And vendor will be optimized for specific requirements. So if I'm building, a very simple mobile service, I don't need the very expensive full feature evolved packet core. I might use something much simpler for that simple service compared to a traditional, mobile service.
Okay, sorry, I was hitting the wrong button there. Here's another question from John. The monitoring infrastructure seems more complicated than is used in static networks, and monitoring plus slice management seem critical. Will the increased complexity make it difficult to perform adequate monitoring under conditions of high load and congestion? Will coordination across slices be possible, enabling transfer of resources where needed?
Actually, I think NFV will make this sometimes easier. I will give an example. It's definitely going to be complex in certain ways, but I can give you an example of segmentation, which is something we will not be able to do in the traditional network. Segmentation means you have a problem and you want to find where the issue. Active testing is the best way to know where the issue is. So in the traditional network, you will have to deploy probes everywhere between every 2 nodes so that you're able to do that kind of segmentation test. Where today with NFV, you can actually deploy these probes on demand to do a specific test, and then you can remove them. You can also do a coordination between passive monitoring and active monitoring, which will help you in optimize passive monitoring. Before, you used to have to deploy in the physical network like massive number of probes to actually monitor the network so that you can find where the call fails. Where actually a combination of active monitoring that triggers passive monitoring can actually optimize passive monitoring. So I think it's going to bring a mixed bag of things that will make us to do it easier and much more efficient, and might bring also some complexity that we will have to deal with.
Okay. And this one is from Sathya. Do you see network slices being sold directly to end user? For example, a manufacturing company buys a slice to manage their factory robots and sensors with enterprise-grade SLAs.
Yeah, well, I mean, I think that's we'll call it the untempered vision of network slicing. I mean, I definitely think that I've heard, the Nokias and the Ericssons of the world talking about that as something that is, it's part and parcel to a lot of the use cases. If you're talking about, for example, factory automation, as far as when that's going to happen, I think a lot of it is going to coincide very closely with the rate at which networks can be automated and closed loop automation, because you're really talking about the need for this stuff to be kind of ordered, provisioned, assured, and torn down again in a closed loop fashion. So I do think that the vision is there, and that's I think that the vendors would like to sell that vision to the operators. How quickly we get there is maybe a question for EHAB to weigh in on.
Yes, so I see that actually, and that's maybe more for operation as well. If that's going to be the case, definitely the architecture enabled that. The question, would service providers and the owners of the network will open that? I assume yes. This is what we hear in many presentations. What would be the business model? Selling infrastructure as a service. When the business model meets the requirement, then I'm sure that will happen. And again, that will impact service assurance massively, because it means that service assurance can be also sold as a service to these enterprises, so that they don't have to build all these things from ground up. They actually just need to build the service. They don't need to implement the OSS from scratch. So a modular service assurance that can be tailored for different types of operation, whether it's IT centric or telco centric, is extremely important.
Okay, and maybe we can take, well, one more question, since we're right on the hour. Unless you guys want to take a few more, maybe 2 more questions. So, well, here, this was quite a long one. Like, what can we expect happening in the next 4 to 5 years? What's the order of things that will happen?
I can take that from Expo point of view. I think we see 3 main steps. One step, which is virtualization, building the cloud and virtualizing component. Whether they are orchestrated or not orchestrated, there is still a OpEx benefit of doing that. The second stage will be with open APIs to actually start doing automation and building automation on top of these virtualized component with and orchestration. So that's the second step, and that's definitely will save. The first step saves CapEx. The second step saves OpEx. Then finally, DevOps. That's the final stage where basically building a network that is flexible and agile to build several services. Now, I don't see that these steps will happen in a waterfall model where finish the first and then go to the second. We see service provider actually working on these 3 planes at the same time. And when the business model works, then it will scale. So this is how we see that. So don't see a waterfall model that with a roadmap that things will be finished first and then the next one will come. We will have to work on all these fronts at the same time.
Yeah, I would agree wholeheartedly with that, and just maybe put a bow on it by saying, with respect to 5G, the 3GPP standards are going to be important. I think the 5G NR standards that came out are getting the ball rolling, and I think that's something that's making operators feel more comfortable with the ability to start to deploy standards-based 5G networks. But then, there's a lot that's kind of, especially with around service definitions in release 16 that's expected next year, that's not even, that are still very much in the working group. So, I think that with respect to the ability to virtualize networks, everything Ihab said is, 100% agreed. And then, like I said, 5G standards are going to be important, and there will be an element of waiting for that before we see, large scale rollouts.
Okay. Are you guys up for one last question, or just going to throw one out from a reader? Do resources involved in network slicing do resources involved in network slicing are also resources on UE, since the mobile edge computing, for example, customer devices, can also be involved in overall network performance? Does anyone want to take that one?
Yeah, I'd probably give a real high level answer, so I don't, I think mobile edge compute or just multi-edge compute is very important for, a lot of sort of the high end use cases. Mm-hmm. And, yeah, that's a tough one. I mean, I think that because we're really talking about, you know, AR, VR, some of the autonomous driving and some of the real ultra low latency use cases, you know, I think that, you know, I think that this question, there's probably some truth to it, but I think it's a complex question that probably is still quite a bit to be determined. That's also going to go into the equation.
Yeah, thank you, Jason. So basically what we can do with the questions that are left over, we'll answer them offline, and we're out of time now, and looks like, you know, we've got to end the show. So once again, I would like to thank our panelists, Jason Marchek of Global Data and Ihab Mana of Expo, for your presentations and your insightful comments. Thank you to the audience for submitting questions. The replay, slides, and report will be available from rcrwireless.com. This has been RCR Wireless's webinar, How Network Slicing Promises to Unlock the Value of 5G. I've been your host, Susan Rambo. From all of us, thank you and goodbye.